Morning, everybody. So like Richie said, I work on the Kraken team at PayPal, which is a thin layer on top of Express. Most of my work ends up being in the internationalization and localization. Or, long story short, what I do is create increasingly complicated ways to concatenate strings. Now, why are we making complicated ways to do that? But what that ultimately comes down to is that we need to make our applications maintainable. And each of these strings comes from a different place, from a team with a different responsibility. I'm going to come back to this later. But first, I almost didn't give this talk because I thought, like, there's any programmers out here who don't read source code. And then I met a bunch of programmers who don't read source code. I talked to a bunch more who wouldn't read anything but the examples or just the API documentation, and a whole bunch of beginners who felt that reading a new piece of code was intimidating and they didn't know where to start. And a lot of people, when they were maintaining software, they would do almost anything not to read the source code. So what do we mean when we are talking about reading source code? Sometimes you're reading for comprehension, to understand what this does, or to find bugs. Quite often you're searching in the middle of debugging and you have to read and actually figure out what's going on. Reading to find interactions or to do a code review. Sometimes you're reading just to figure out what the interface of this is, what is and is not in this module. And we read to learn. And so not reading the source code is a huge opportunity missed. But here's some of the things. Reading isn't linear. We think we can read source code like a book. Crack open the introduction of the README and start there, and that's the go read on chapter by chapter, chapter 1 to 2, on toward a conclusion. Reading source code isn't like that. We can't even prove that a lot of programs have conclusions. Programs don't even necessarily terminate. So we skip back and forth from chapter to chapter, module to module, and we can read the module straight through, but we won't actually understand the definitions that are coming from other modules. And we can read an execution order, but we won't necessarily know where we're going until we get there, and we won't understand the whole. So we end up reading through in a nonlinear, referring back and forth way. So when you start, do you start at the big entry point of a package? Do you start with the index.js and trace down from there? Or in a browser, how do you even find the entry point? Quite often you have to scan through and figure out what do you actually load and where does this begin. I suggest to a lot of people, start with the biggest source code file and read through from there. Or try setting a breakpoint early on and trace through the execution, or set it deep into some piece of meaningful code and then read the stack as it stops at the breakpoint. So who here reads any of these kinds of source code? All right. How about any of these? Other people's JavaScript. All right. That's what I'm talking about. So there's another kinds of source code. How many of you read any of these? Or understand any of them? There's a lot of study of some of these. Algorithmic code in particular, there's a lot of study around how to read it, how to write it, how to describe an algorithm around, because this is what academia has produced, those mathematical bits of source code. But the bulk of what we deal with, especially as web programmers, but in general, we deal with a lot of the other kinds. We deal with a lot of glue, putting together interfaces, and we deal with interfaces themselves and trying to understand what we've been handed, and not just another implementation of a hash tree or a B-tree table. Now, a piece of source code may be more than one of these things. So let's go over some of them. Glue. Not all the interfaces that we want to use play nice together. Glue is the connections, all of the plumbing, and all of those pieces. Middleware, all the promises and callbacks binding code that we end up dealing with in Node. Inflating arguments into objects or taking objects and breaking them apart. Those are all glue. When you're reading glue, you look for how these interfaces are differently shaped and what do they have in common. Here's an example. This is from Ben Drucker's Stream to Promise library. These two interfaces we're talking about are node streams and promises. And the things that they have in common are that they both compute a result until they finish. In Node, that finish is an event or an error, and in a promises, that's a resolution or a rejection of the promise. Now, one thing you can know here is that event emitters can actually emit the same event multiple times, whereas promises can only be resolved once. There's actually a guard in the promises implementation to prevent you from resolving it multiple times. So that's something that a piece of glue like this may have difficulty with. We have to understand those limitations. That's something you would end up reading for, is finding what do these things have in common and where are they different. Something else to think about, how are errors handled? This is another bit of glue, the kind of thing you'd find in a web application dealing with forms. It's worth asking, do any of these things throw an exception? Or maybe they coerce their values into being okay enough? Or do they outright delete a bad value, like the age validator there? Are these the right trade-offs for the context they're operating in? Sometimes we want to throw exceptions out and ensure perfect correctness. Sometimes we want to allow as much as we can through so that we get some data. Another thing we run into are the interface defining code. You know how you have some modules that are used in one or two places and you hope nobody looks too closely because they're just little utility functions? Interfaces are the opposite of that. Interface defining code are the hard boundaries of your module. And this is a cut-down version of node.js with function bodies removed. This defines what an event emitter does and what it is. Some things to ask here. Is this complete? Is this the sum total of how this is used, or is there something else further up the chain that we need to be understanding? Are internal details exposed? Things like that, using domains. That is a internal detail that has some vast consequences sometimes. If you have strong interface contracts, this is where you'll find them. This is where type checks end up, or other things that really define how you must use this. And when you're looking at this, if you make an error using it, will it tell you that it's your fault? And if there's an error in the implementation, will you be able to tell that apart from an error that you've created? So then we can look at implementation code, the meat of most of our applications. This is from Ember Router, and this is a kind of a particularly good example of what we find. Things when we're reading here is we're looking for how it fits into the larger whole. This is from a class. Ember Router is a JavaScript class, so it uses instance variables for its input. It assumes that there's some state to begin with. We ask here, what are the public interfaces to this module? In this case, just the start routing function. It doesn't take any arguments. Does anything here need validation? Is there any assumptions being made that we'll need to filter out? What are the risks to changing this? What are the implications of that? And what is the lifetime of some of these variables? This one is particularly easy because there's nothing, it takes the input from its instance variables, but it doesn't actually save anything with a long lifetime, so we're not dealing with state that has a long persistence. Although, maybe we should look at that underscore setup router method. That's probably where a lot of the meat lives. So there's a concept called process entailment. It's pretty easy to see what functions call what other functions, but the reverse relationship is a lot more interesting. One of the things you can look for when reading source code is looking at the implementation bits and seeing what has to be set up to get things into the state we need to be in to operate. Is that state explicit? Is it passed in via parameters? Or is it assumed to be there on instance variables? And is there a single path to get there, or do you have to execute several unrelated steps before there's enough state that you can execute this without an error? So then there's a special case of implementation code, algorithmic stuff. Most algorithms aren't too terribly exposed to the outside world. They may expose a data structure or a couple of simple primitive operations. But this is where you run into the exceptions to the rule that comments should explain why and not what. Algorithmic code ends up being the thing where if it was a trivial algorithm, it would already be in our standard library. So we're doing something careful. Performance matters in a lot of algorithms. So the exactly how and what it's chosen to do over another implementation ends up being pretty important. So you end up with comment-heavy code. This is actually a piece from something I've been writing. This is the stuff that people with CS degrees get to drool over or maybe have traumatic memories of. Continuing on, when you're looking at algorithmic code, you usually need to know what data structure you're operating on. This is a snippet that just operates on a simple array or list. It's building a list of symbols and making sure that there's no duplicates. But you look for hints, too, as the running time. Like, given how much input, how long is this going to run? In this case, this has got a big O complexity of at least n times m, because we're doing two loops inside of each other over the input. And actually, inside of that, there's an index of operator, which itself in JavaScript is also a loop. So we've got another factor on our complexity here. And actually, I found a bug in here as I was reviewing this slide. I'm using the index of twice, and I could be caching the value there and save myself quite some time. And I'm glad this is not the main body of the algorithm I'm So then we can get into configuration. The line between source code and configuration is super thin. There's a kind of constant tension in configuration code between having it be expressive and to be direct and to be readable. This is an example from an express configuration where we're changing a value based on an environment. If there was another dimension of freedom here, we could end up with a combinatorial complexity. So you end up with permutations where only in the test environment, only when the database is set to such and such an endpoint does this bug show up. And so that's something we end up looking for, is how many degrees of freedom does this configuration have? Coming from the Kraken project, that's something that we cared a lot about at PayPal. And so we can squash our configuration down into JSON. We made it as simple as possible, and it's actually traded a lot of that expressivity and succinctness for this giant swath of JSON. But what we've allowed there is that it's almost impossible to make one of these permutations to have these bugs that are hard to chase down. There's a reason that a lot of tools use INI files or simple key value pairs for configuration, because it's hard to overload. And there's also some interesting constraints to configuration code because they have to fit in weird places. Sometimes configurations are stored in environment variables where you don't have types. They're just a string. Sometimes they store security-sensitive information, keys, or credentials of some sort. And quite often they won't be committed with the source code, so they have a different life cycle, different maintenance perspective. And sometimes they are machine writable, because we'll create a configuration tool to actually create a configuration file for us. And so easy to write and easy to machine create is sometimes an important factor in configuration code. Another thing we run into is a kind of a special case of implementation is task code. So I'd ask, what does charging 50 credit cards have in common with building a complex piece of software with a compiler and sending 100 emails? And there's a couple of things there. The things that they have in common are a need for transactionality. If you have a compiler that leaves its build products around, even in the case of a failure, you're going to end up having bugs because you'll use build products that are incomplete. So the files either need to be created or not exist at the end of the process. Credit cards, if you double charge your customers, they're going to be very unhappy. So the process has to happen exactly once, or it has to happen not at all. Or sending emails. If you end up in a retry cycle and flood somebody's inbox, or conversely don't deliver an important notification, that's a problem as well. So you look for places in your source code where transactionality is important, and read for those places where things are synchronized and the errors are checked. Quite often batches and tasking code like this needs resumability, because if you're in the middle of 100 things and you have a failure, you need to stop the ones that have failed and then continue on from there. And quite often task code is very sequential. You do this thing, you do this thing, you check for the errors, and then you do any cleanup, and then you loop. If there's loops, they tend to cover the whole thing instead of being a tight inner loop. Something else we can talk about is, how do you read messy code? Quite often I see a lot of people, they glance at the source code and they will see, oh, this is nicely indented, I can read this. But what happens when you're handed this? This one we get to blame Isaac Schuliter, the author of NPM, for. This is actually reverse indentation. He did it as a troll. But you can put on some rose-tinted glasses. Pharos' standard formatter here actually just takes that and rewrites it into something that's a lot easier to read. It's okay to use tools when you're reading. This is an active process. You can read with more than just GitHub skimming through the source code. You can download it, you can run commands, you can actually inspect what's going on. So that if somebody hands you this, you can turn it into this. Uglify has a beautifier mode that will unpack compressed minified JavaScript. It won't restore the variable names, but it'll at least let you see a little bit more of the structure and what's going on. If you've ever debugged a module system or a build failure during like packed web code, this trick is a lifesaver. So there's another thing you can look for when you're reading source code, like trying to understand what the author meant. There's a lot of tricks for this. I'm going to go over a whole bunch of specific cases. You can look for guards and coercions. In this case, you can tell that whatever argument this is passed in, it's a number. And it's actually being enforced in the first case. Another case is when it's coerced, it'll be interpreted as a number. The way errors are handled in these cases are very different. One throws an exception, the other just gives a nan, which if you compare it is false, and otherwise, if you multiply it with other numbers, it's still nan. That's actually an error propagation technique that was deliberately chosen when the floating point specification was created. And there's actually techniques for dealing with propagation of errors in numbers that you can use. But that tells you a lot about how the author was thinking about the problem. You can look for defaults. In this case, the argument is obviously supposed to be an object, because if you don't specify it, it creates one. Another trick you can see is a double equals comparison with null. Quite often that means that you're checking to see whether the user of something supplied a value at all. If they set it to something even false, you believe them. But if they left it undefined as an undefined or passed in null, meaning take the default, you can choose the default variable or the default value. If you're looking for layers is a great thing. If you've got the request and response objects in Express and you go tracing through the code, how deep do those go? Is there a clean line between the business logic and the web layer, or is everything written in terms of the request and response? Finding those boundaries can be really useful for understanding what the author meant and how things are laid out internally. You can look for tracing, debug logs, and whether they form a story or whether they just have the leftovers from the last few bugs that happened. Are these debugs unconditional or are they conditional? That can tell you a lot about how the state of the code, how maintained it is, and what the thought process is for the authors as they've been debugging it. Another thing that you'll find is reflexive code. When things are creating identifiers on their own, especially when you're dealing with language handling code that reads and understands JavaScript or reads and understands concepts implemented in terms of JavaScript, you find people being clever and creating their own functions and creating their own names for things. And this will actually stymie people who search through and try to read source code by grepping for identifiers, because those identifiers don't exist in the source code. Quite often you can do things like print out a generated function or even a callback and see what function is this and see where it came from. And another thing to do is look at the lifetimes of variables. Who initializes it? Who makes this value change? Because 99% of the time, when you see a value in a program, someone somewhere typed that into a keyboard, generated it from a random number generator, say for a key, or computed that number and saved it. Somewhere else, sometime else, some other human is going to be affected by that value. Who are those people? Go read and look and see if you can figure that out. Who chooses what these values are? How do they know that they were right? And you can start analyzing, is this value going to change? And then, is this value going to be in multiple places at once? You can take the example of a user in a registration field. If they've put their name into the application at one point when they signed up, later on you'll address them by that name. But if they're in the middle of changing their name, that may not be their name anymore. This value is in multiple places, and you may have to deal with the fact that it's not actually coherent and consistent. Another thing you can do is look for hidden state machines. You've probably seen code with a couple of Boolean variables tucked in it somewhere, and they get set as you run through the code. That's actually a hidden state machine. You can end up in cases where you haven't hit ready yet. Later on, you'll hit ready, and then as you run through the code, you'll end up in a finished state where things have completed. You can actually lay that out on a truth table and see that there's a case here that wasn't handled. If something finishes without becoming ready in this simple case, maybe that's an invalid state, or maybe that's where errors live. See if there's a path through the code that can actually end up with those values set that way. And you can see whether modeling that as a state machine would have made it clearer. And you can look for composition and inheritance. Going and just looking to see, are these made out of parts that I can recognize, and do those parts have names? That's a huge help when reading through source code. And you can look for common operations. Mapping, taking a list of values and transforming it to a different list. A reduce operation, taking a list of values and getting a single value out. Or a cross join, where you take two lists of values and you're comparing them for some purpose. So with that, it's time to go read some source code. I hope you can look deeper and understand everything you're depending on a lot better. Have a great day.